The properties of logarithms can be used to solve exponential equations. I want to look at a couple examples in this video using method 1, which is kind of a special situation where we can make the bases of the exponential expressions match. So in this first example, notice that 36 is equal to 6 squared. So we can rewrite the equation as 6 to the x minus 1 equals 6 to the second power. And then, because exponential functions are one-to-one and have inverses, we can simply set the two exponents equal to each other. And that's the heart of method 1. If we can rewrite an exponential equation so that the bases match, we can come up with an equivalent equation by setting the exponents equal to each other. And then we quickly see, adding 1 to both sides, that x equals 3. Of course, it's always nice to check our work when we can. So, this is our solution. If we plug the 3 back in for x. The next example is a little more complicated. It's a little trickier to see. The common base, if you think about that for a moment, the common base of this equation is going to be 2. And to see how to rewrite that, you might realize that 8 is the same as 2 to the third power. And so that's being raised to the x. So a property of exponents allows us to multiply those two. If you have something raised to a power, and then that expression raised to another power, that whole thing raised to another power, we can multiply the two exponents. So on the left-hand side we have 2 to the 3x. On the right-hand side of this original equation, we can do a couple of things. First, the square root is the same as raising something to the 1/2 power. So I can think of that as 2 to the 1/2 power. And then, because it's in the denominator, we can translate that into a simpler exponential expression by using a negative exponent. So this turns out to be the same as 2 to the negative 1/2. So now we have a statement with equivalent bases. We have two simple exponential expressions on either side of the equation. Both of them have base 2, and so we can set the exponents equal to each other. So I get 3x equals negative 1/2, and to solve the equation I want to multiply both sides by 2. That's going to cancel out the denominator on the right hand side and give us 6x equals negative 1. And then dividing by 6 gives us our final answer. So we end up with x equals negative 1/6. Again, we could take that solution and plug it back in and see that it makes sense. We might use a calculator to do that to see that the decimal values on either side of the original equation are the same. And let me just mention one more time, this is a special situation. It doesn't work for every exponential equation. For more complicated situations, we need to use method 2, which involves the power rule for logarithms, and we'll look at examples of that in a separate video.